The geological history of Earth follows the major events in Earth's past based on the geologic time scale, a system of chronological measurement based on the study of the planet's rock layers. Earth formed about 4.54 billion years ago by accretion from the solar nebula, a disk-shaped mass of dust and gas left over from the formation of the Sun, which also created the rest of the solar system. Earth was initially molten due to extreme volcanism and frequent collisions with other bodies. Eventually, the outer layer of the planet cooled to form a solid crust when water began accumulating in the atmosphere. The Moon formed soon afterwards, possibly as the result of a Mars-sized object with about 10% of the Earth's mass impacting the planet in a glancing blow. Some of this object's mass merged with the Earth, significantly altering its internal composition, and a portion was ejected into space. Some of the material survived to form an orbiting moon. Outgassing and volcanic activity produced the primordial atmosphere. Condensing water vapor, augmented by ice delivered from comets, produced the oceans. As the surface continually reshaped itself over hundreds of millions of years, continents formed and broke apart. They migrated across the surface, occasionally combining to form a supercontinent. Roughly 750 million years ago, the earliest known supercontinent Rodinia began to break apart. The continents later recombined to form Pannotia, 600 to 540 million years ago, then finally Pangaea, which broke apart 180 million years ago. The present pattern of ice ages began about 40 million years ago, then intensified at the end of the Pliocene. The polar regions have since undergone repeated cycles of glaciation and thaw, repeating every 40,000–100,000 years. The last glacial period of the current ice age ended about 10,000 years ago. Precambrian. The Precambrian includes approximately 90% of geologic time. It extends from 4.6 billion years ago to the beginning of the Cambrian period. It includes 3 eons, the Hadean, Archaean, and Proterozoic. Hadean Eon. During Hadean time, the Solar System was forming, probably within a large cloud of gas and dust around the Sun, called an accretion disk, from which Earth formed 4,500 million years ago. The Hadean Eon is not formally recognized, but it essentially marks the era before we have adequate record of significant solid rocks. The oldest dated zircons date from about 4,400 million years ago. Earth was initially molten due to extreme volcanism and frequent collisions with other bodies. Eventually, the outer layer of the planet cooled to form a solid crust when water began accumulating in the atmosphere. The Moon formed soon afterwards, possibly as the result of a Mars-sized object with about 10% of the Earth's mass impacting the planet in a glancing blow. Some of this object's mass merged with the Earth, significantly altering its internal composition, and a portion was ejected into space. Some of the material survived to form an orbiting moon. Outgassing and volcanic activity produced the primordial atmosphere. Condensing water vapor, augmented by ice delivered from comets, produced the oceans. During the Hadean, the late heavy bombardment occurred, during which a large number of impact craters are believed to have formed on the Moon, and by inference on Earth, Mercury, Venus and Mars as well. Archaean Eon. The Earth of the early Archaean may have had a different tectonic style. During this time, the Earth's crust cooled enough that rocks and continental plates began to form. Some scientists think because the Earth was hotter, that plate tectonic activity was more vigorous than it is today, resulting in a much greater rate of recycling of crustal material. This may have prevented cratonization and continent formation until the mantle cooled and convection slowed down. Others argue that the subcontinental lithospheric mantle is too buoyant to subduct, and that the lack of Archean rocks is a function of erosion and subsequent tectonic events. In contrast, the Proterozoic, Archean rocks are often heavily metamorphized deep-water sediments, such as greywacke, mudstones, volcanic sediments and banded iron formations. Greenstone belts are typical Archean formations, consisting of alternating high and low-grade metamorphic rocks. The high-grade rocks were derived from volcanic island arcs, while the low-grade metamorphic rocks represent deep-sea sediments eroded from the neighboring island arcs and deposited in a four-arc basin. In short, greenstone belts represent sutured protocontinents. By 3.5 billion years ago, the Earth's magnetic field was established. The solar wind flux was about 100 times the value of the modern Sun, so the presence of the magnetic field helped prevent the planet's atmosphere from being stripped away, which is what likely happened to the atmosphere of Mars. However, the field's strength was lower than at present and the magnetosphere was about half the modern radius. Proterozoic Eon. The geologic record of the Proterozoic is more complete than that for the preceding Archean. In contrast to the deep-water deposits of the Archean, the Proterozoic features many strata that were laid down in extensive shallow epicontinental seas. Furthermore, many of these rocks are less metamorphosed than Archean age ones, and plenty are unaltered. Study of these rocks show that the Eon featured massive, rapid continental accretion, supercontinent cycles, and wholly modern orogenic activity. Roughly 750 million years ago, the earliest known supercontinent Rodinia began to break apart. The continents later recombined to form Pannotia, 600 to 540 Ma. The first known glaciations occurred during the Proterozoic. One began shortly after the beginning of the Eon, while there were at least four during the Neoproterozoic, climaxing with the snowball Earth of the Varangian glaciation.